Can you hear me well?
Yeah, I can hear you perfectly.
All right. So, like Darlington said, okay, thank you, Favor. Um, we are going to be discussing ERC 20 token today. Okay, we talk about its functionalities. It's going to be a live coding section actually. Then we talk about its usefulness. We deploy it to our local machine, and then of course everything will be done using a remix. So without further wasting our time any further, I will begin to share my screen. Let's see. I think the entire screen. Yeah. Okay, I need you to confirm you can see my screen right now.
Yeah, I can see it. Well, I don't know if it's network or something. You just hang it. Okay, I can
Is
see
that
it now.
okay? Okay, okay. So, all right. Thank you. So I have a very well kind of small slide that we'll rush through and then we go into the coding. Um, so ERC20 is like a fungible token, right? Fungible token is a token. Um, it's kind of replaceable, right? So if, for example, you have $1 and I have $1, we can exchange it because $1 that you have and the $1 that I have are equivalent in value. Okay. So um, now ERC stands for Ethereum Request for Comment, while the 20 there is like a proposal identifier number. Now this means when you talk about ERC20 now, it's a standard, right? And that means I can actually create it. Favor can create another one. So everybody on the call can actually create it. But the problem with this is this. The way I implemented my own token is not how Favor will implement his. You get that? And in the end, if we want to like say um an exchange or a wallet wants to integrate our token, they will have difficulty, building it up due to the different implementations. You have to come up with a system that works for my own token, come up with a system that works for Favor's own. Like it will be like chaotic. So in order to avoid that, uh, we have a standard. They come up with a standard, right? And say, okay, every ERC20 token is supposed to have so functionality. Now, and they voted. Hence, the reason we have this request or comments. So, in the end, ERC20 was approved, and hence, we're here today. Now, the components basically it has like six mandatory, right? Mandatory functions in it. Now you can have more than six, obviously, but this six is very like every ERC20 token must have it. And they talk about the total supply, okay, of the token, the balance. So when we pass an address here, we should be able to get the balance um, within the address. Then we talk about transfer. The token is meant to be capable, like to transfer value. The person calling this particular function here, we transfer um, this value here, U in 256 to the address 2. Okay. Now moving on. functions, we have the transfer from, approve, and allowance. Now, on the norms, Bitcoin only can do these three functionalities, but with the power of Ethereum, on Ethereum blockchain, we can um, write smart contracts. We have dApps, right? So we can give our dApps, our smart contracts, an authority to spend our token. Hence, the transfer from, approve, allowance. Um, let's move on to the next slide. Okay, the component continues. Now you can have all these kind of optional uh, symbol and then the decimal. Okay, we have two mandatory events, like every single ERC20 event month. ERC20 token must have these two events. Have the transfer event and then the approval event. We implement all these and see how they work. I think that's the end. So right now we have to move on to the implementation. So I believe we've been introduced to Remix. I have it open somewhere here. And I go to my contract folder. I'll create. I'll call it ERC20. I open. Now, because we are kind of lazy, I guess, I just copy this license and then I'll be using it right here, of course. So first thing first, we already talked about the functions we have in an ERC20 token. So in order to get started, we define our contract ERC20, right? And then we open it. So to begin with, we define the state variables. We start with uint. Now, as I'm going on, if you have question, of course, you can always call my attention. You can use the chat box as well. Let me check, make sure we don't have anything. Okay, we're good. So back to Remix. Say uint 256. By setting it as public as the visibility, and then we call it total supply. Okay, that's someone call. All right. So we need to define the name of the token, right? So we go for, that should be a string, make it public, and then name. Talk about the symbol. Symbol should be string as well. I'll make it public. Now, before now, I believe we were told that once you define your variable functions as with this public kind of visibility, it automatically generates a getter function for you. So so we have the symbol, and then we can have uint as for the decimal, uint 8, right? Set it as public as well. decimal. Now to initialize these variables, we use a special function, called the constructor, right? Constructor runs once at the point of deployment. So type constructor, open it up. It's gonna take a string, give it the location we want the string to get executed, name. We also have another string, memory as well. This was single now. Go. And then we open up curly braces. So we set our name equals underscore name. Terminate the process single equals underscore single process. Now for now, let's keep this the way it is. We actually need to mint the tokens to an address, but let's just keep it the way it is for now. Now the next thing to do after this, instead of using this public decimal something something the way it is, let's hard code it so that we return a specific value, right? So I'll do something like function decimal I will set it as public. So while we're doing this, I should just take this out because the two is almost the same. They are the same. Without writing this guy here will generate a getter function for us. But let's hard code it and then so it's gonna be a pure and it returns return a uint 8 uint 8. This case, sorry, to return 18. That's like in Ethereum, the suffix is usually 1 to the power 8. So that's what we have here. Now the next thing to do is to implement the transfer function. Remember, the basic function we have is this guy, the name, I think it's somewhere here. Let's go back to the slide and confirm it. Total supply, balance off, and transfer. So now we're about to implement transfer function. This it basically allows us to like transfer our token from one Ethereum address to the other, right? So we have function now, but before we get started, we need to keep track of the transactions as they go, right? Because from what we can see here, this is taking an address and is tied to a value. So we have to use mapping, right? And I will call my mapping, come up here, define the mapping just before the constructor. So the mapping. We're mapping from an address to uint. Uint 256. Also, we make it public just so it will generate a getter function for us. Call it balance off. Now back to our function. We have function call it balance, right? Transfer please. Um, which takes in the address we want to transfer to. Address, and this address will be the recipient. That correct? Okay, recipient. And then the amount we want to give this recipient 256. Um, this is wrong. U int. Okay. So the amount, just give it this, and then we set it as external because other contracts can call it as well, right? And then now it returns a bool as true or false. Once the transaction is successful, it's going to be true, else have false. So then open. First of all, we get the address of the sender, right? And then we do it by saying uint um, 256 sender, call it sender address, sender balance is equal to then we talk about the mapping here, balance and the key, right? So we have balance of ms. msg sender is the person calling this function, right? Okay, msg sender. And we can know the process. Now, before we proceed, we need to make sure that the balance, the person, is enough, right? Before they can transfer the token out. Because if you don't have enough, you can't give what you don't have actually. So go with require.
Okay, I think we lost CC, or is it my network that's giving issues? Can you guys hear me?
I think we lost him.
Yes,
Oh,
we can hear you. I think we lost him.
yeah. Just give him a while. I'm sure he'll be back soon.
Exceed.
Okay, CC, I think we are losing you. Look, can you hear me? Oh, CC, can you hear me?
Yes, I can hear you.
Okay, I think we are losing you for a bit. Like your network is giving you
Is it checky?
is a bit better now.
Okay, okay, okay. So after having our required statement here, we now how it works is this: if this is true, this is going to return a true or false. If the condition we have here is true, then the code continues like the next line execute, right? And we have that if the sender has enough, now we want him to send the token. And we do that by saying balance of that of the MSG sender is right. We subtract transfer. And after that, we then set the amount the receiver received. We do that by saying, now we are using this mapping here, right? So we go all the way to saying balance of, now that of the recipient. Okay, is equal to you can say another balance of the recipient. That's the initial balance the person used to have plus the amount that was given to them. But instead of going the long, we can use the this notation here, right? Then add the amount, terminate the process. So if everything goes as planned, we just return true. Sorry, return true. And now we have our transfer function ready. Now with this, like we said earlier, we actually have our core functionalities of an ERC20. Okay. Now to transfer token on behalf of someone else, we need to implement another set of functionalities. That's what you call transfer from, approve. So yeah, this is a transfer function, right? In the end, it's meant to transfer by its name. Transfer from also, if we can guess, it's meant to have a transfer like functionality in it, right? So in order to avoid code duplication, we are going to make this current transfer we have an internal function, right? So that it's within our contract and then use it to update this transfer here. Now, how the transfer from works is we need to create a second mapping, right? That maps the owner and then to the sender tied with the amount the owner wants the spender to spend. Okay. So with that in mind, we come up here and define our second mapping now. We call it mapping of address, right, to another mapping, 2D mapping now. And then it takes another, that's spender's address. This is the owner's address. First address here is the owner's address. The second address is what? The spender's address. And maps it straight to what? uint, the value 256. All right. And then we name our mapping what? Public allowance. And where the process. Let me see. Okay. Going back. Yeah. Is that someone's hand up or what? Okay.
Yeah, can you hear me?
Yes. Yes.
Okay,
You have a
so I was
question?
looking. Yes, yes. It's more of a
Okay.
suggestion. I
All
was
right.
looking at the transfer function for
Yeah.
transferring tokens. So the line 24 and line 28 seem to do the same thing. Like that sender's balance. We could just remove that and just add the minus equals amount, and then we can remove the sender's balance.
Okay. Let's stick to what we have
Okay,
at the
okay,
moment.
cool.
Okay. Yeah. Thank you. So after this, we then take this down. Let's just duplicate this. Okay. Copy. Come down here. Paste. Yeah. So right now we are making this guy a private. We're gonna make it from change it from being external to a private function because we want to use it just within our contracts. Private. Um, and then it returns a bool as well. Now instead of this function, now we need to add one more functionality, an argument here, right? So that we have a sender because what we had here, we're assuming that the person calling this function will be the sender, right? But right now, we want to explicitly say that another address is guy the sender. Sorry. Yeah. So if this changes, okay, this guy is warning me. If this changes, then we have to update what we have here, right? Just remove MSG, okay, and then we'll also update it right here. Okay, I think that's about that. Now there is something we actually needs to check for because someone transferring token here could make mistake and send it to what we call a zero address, right? Zero address. If you send your token there, well, you can't get it back, right? So let's implement like a check actually, sanity check. You call it um at the recipient, right? Say recipient. Uh, recipient. It's not
Okay, I think your
um
screen. Sorry to cut you short, though. I think your screen is currently like hanging. I don't know. Okay, that's the
is it from
response.
my okay? Is it okay now?
Yeah, it's responding now.
Okay. So we have is equal to it's not equal to address zero because we don't want to lose our token. So now we can actually attach the error message as well. Say ERC20 transfer to address zero, but we don't want that to happen. ERC20 transfer to address um address zero. Okay, I need to make this a double quote to avoid this kind of um necessary issues. Okay, yeah, so this works. So here right now we are trying to like the recipient here, the person we want to send the funds to, the token to, by checking that um it's not a zero address, because we don't want to lose our token. So after which we now set the balance. Let me see. And then, like we said earlier, we check to make sure that the balance is actually greater than the amount we want. Everything works as it is now. In the end, um, yeah, we'll return this. So the next function to um, now we have to like implement the transfer from function, okay? But since we've done this, we can now comfortably clean this out, right? And then we just call the function, we just implement it right here. We say return um, return underscore transfer, yeah, except yeah, sender. Okay, I think this guy is good to go, except now update this guy to msg dot sender, right? Msg dot sender, because the person calling this function is this guy here. So the next thing we have to implement is the transfer from. So we start by writing function transfer from, and then we have address of the sender, right? Address of the sender, then address of the recipient. I hope I'm spelling this right. Okay. And then of course the value as unit 256 unit 256. Make it external so that it can interact with other contracts, and then means a do as well, right? Do. So after that, what's next? We set the amount to be transferred. Okay. Now, to set the amount to be transferred, we are going to use the mapping we defined here. Okay. The amount, because you are not meant to transfer more than you are allowed to transfer. Now, it's important to understand the person transferring this token on your behalf is actually someone you trust, right? So it could be maybe smart contracts that you yourself wrote. Like it has to be someone you trust. So now we want to implement in transfer from. Where is the error coming from? Open this out. Yeah. So we say you int 256. That is the current. Call it current balance. Okay. Or the current allowance, the amount allowed at the moment, right? balance is equal to, we get targeting this guy here now, the middle guy. Where's the mapping again? Okay, we're targeting this guy here. So what we have here now is we see allowance, which is the name of the mapping. Trying to get the sender. Oh, sender, and then we target the same second guy. That's the MSG dot sender, right? Okay. So after that, we need to make sure that the amount, the recipient, I mean it's not more than what the current balance we have here. Okay, this amount here, I think I'm making a mistake here. There should be an amount here, yeah. Amount. Okay. We need to make sure that this current balance here is actually greater than what we want to transfer, because if it's less, I mean, we are not doing magic, right? Everything works the way we code it. So again, we do our sanity check, require that current balance, but it's not giving me auto completion, is equal, greater than or equal to, right? Amount. Okay. Current balance is greater than or equal to amount. Okay, why am I getting error here?
You are missing a semicolon at line 29.
Line 29. Oh, yeah, thank you. Then here we add our error message. Say ERC20 transfer amount. Transfer amount must exceed allowance, right? Allowance. Okay. So if all these conditions now are met, then we are going to subtract the token, right, from the sender, and we do that by saying allowance, talking about the sender now, and then the MSG, that is the person calling the function, right, which is our customer contract, is equal to current balance minus the amount we want to transfer. Now terminate the process, and then go down, we'll return our transfer method. So transfer underscore amount. So with this, we've implemented our transfer from. Please, if you do have a question, you can always ask, and I'll do the best I can to explain. So moving, the next function we have to implement, which is the approve function.
Sorry, I have a question.
Okay.
Can you please remind me the purpose of this transfer function with underscore in front of it, and also the purpose of transfer from with underscore in front of it? Thank you.
Please repeat your question. I didn't get you well.
Okay. I said, can you remind me the purpose of these two functions, the two transfer function and transfer from function?
This transfer and transfer.
Transfer from, yeah, that one.
Okay, okay. Now this is like you are trying to give someone the ability to call functions on your, or, to transfer tokens on your behalf. Do you get that?
Yeah, yeah.
And that someone is someone you trust. And who could that be? It could be a smart contract, like smart contract you wrote, and you trust it that it will do, perform the actions you code it to do. So I don't know if that answers your question.
That would do for now.
All right. So now talk about approve function. Is a way that the owner can allow other addresses to spend their token. Okay, now the owner has to approve, like, okay, I want this guy to enjoy this, right? So we come down here and we have something like um function approve and we have the address that we want to approve the function for, and we call it the spender, person that's meant to spend. Right? And then the amount we want to transfer. Sorry, you ain't always going for the other stuff. You in 256. And then that's the amount you want to transfer. And so we talk about external, but we want to interact with other contracts, right? Now it's going to return a bool as well. Boolean. So now, once again, we have to do our sanity check to make sure we're not. So we say require, and the condition is what? Spender is not zero. So let's add a simple this guy here. Okay, then we go for the ERC20 approve to the address. So, and this might be wrong, but you get the idea. So once this is satisfied, we don't want to send to a zero address, right? Because that's not going to help anybody at all. Rather, we incur loss. So, we set the balance now, and that is using the map we have up and say MSG sender is the person calling the function. Trying to update the amount they want others to spend, and that's the sender now. Is equal to the amount. Okay, we are setting the amount they want our spender to spend, and we terminate the process to avoid issues. Now after that, we return true. Of course, everything goes to plan. Hopefully, just return true. Terminate the process. Now, I believe we have everything we need, right? If we go back to our slide, we have to supply, we have balance of, right? And we have transfer function. What else? Okay, we have transfer function. This is it. Then we'll go on to the next slide. Okay, this guy is changing color. Now, what we can see this transfer from, approve, then allowance. I believe we've implemented everything here, and then however, if we want to deploy this contract as it is, we have not given the contract like the ability to produce, call it maintain actually. So that's the next thing we have to do right now. So if I come down here, maybe right here, try to do something like function comment, because I want it to be like internal or within our contract, right? And then I'll go for these guys, the address we want to mint to, that is to address, and then the amount we intend to mint amount. What else? I'll make it internal. Okay. So even if another contract inherits it, they can work with this. Then we require, because we don't want to, this sanity check is kind of important, right? We don't want to mint to zero address. So I'll simply copy what we have here to save us some time. Come down here and paste this. Now this recipient is meant to change to what? 2. And this guy stays. ERC20 mint. Now say okay. Mint to 0. Yeah, instead of transfer, because it used to be transfer, this is going to be mint. We don't want it. Don't want this happening. Now, if this condition is met, we then update our total supply. We have total supply of here. If you remember, we have it somewhere here, right? Yeah, it's been there like forever. So we are updating it here. It used to be 0. I believe we all know that the default values of variables. Well, if it's a string, it's an empty string, right? But for uint, it's 0. Then for bool, it's false. So currently it's 0 at this point. Now we'll come down here. Next thing we have to do is to update this. Update it with the amount we are maintaining, right? The process, and we'll also update our balance. Balance of 2 as the is equal to amount, right? So with this out of the way, we can now go back to our constructor and set the value, right? So that when we deploy the token gets minted. I think this place should be fine. So we call our function, the function we just defined right now, and that is our underscore means say amount to, right? Now we want to mint to the person deploying the contract. That's the person calling this constructor. So we use MSG sender. And then the amount, let's just say we are minting well, 109, right? Exponential maybe 18. That work. Yeah, that's the power. This guy here. So I believe everything is okay. You have a question here. Yes, you get the code when the so hanging tight. So I believe we have everything we need. We have our state variables, right? And then here we set the values. Okay. Is someone trying to say something? Okay, some Tochuku, please. I'll mute and talk.
Okay, please, what do you mean by 109 to the power of 18? If I'm saying that right.
Yes, yes. That's the amount we want to mint, right? Actually, it's gonna be just 109. You get?
Yeah, but what's the what is E18 doing there? Sorry.
That's the how do I explain it now? The suffix that Ethereum, when you convert it to way, like the conversions. I don't know if we've done that before now. Like it has 18 values, 18 zeros. Like so, one count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, I think that should be that. Right.
In here.
That's the least value. Talking about way now. This is in way. Okay.
Yeah.
Okay, I think I understand now.
Yeah, just like Sissy said, during the second class, we looked at different measurements for Ethereum. We looked at Way, Ether, Fini, Gwei, and the rest. So when you write just 109, right, and you deploy that to the blockchain, it would be automatically interpreted as Way, as that's the smallest unit that's recognizable, right? So basically, when we say e raised power 18, we're saying 109 times 10 raised power 18. So you're changing it from way to ether because one ether is equals to 10 raised power 18 way.
Okay, thank you.
All right. Right. I think if everything is okay, let's just do some kind of sanity check and make sure we are in order here. We have our state variables, and right here we set them, right? The values we want them to be, and this gets wrong once we deploy the contracts. Now we have our main thing, the function, the method that's going to mint this amount of, okay, let's make it 1,000 actually. Yeah, that's stingy. So 1,009, and it's gonna mint this quantity to this guy here. MSG to send that. Here we just had coding the special about that guy, and then we have our transfer function that is meant to transfer. The person calling this function will transfer to the recipient, right? And then the amount the person wants to transfer. So here we are returning it under this function. This is an internal function we have somewhere below. As that person trying to send the token, right? Recipients and then amounts. Did some sanity check here, right? Did some sanity check. Then in the end, if everything works, we update, the transaction. We say, okay, this person has so balance. Is it bigger than the amount he wants to transfer? If so, then we subtract the amount he's transferring from this, and then here we update the recipients, the person receiving, update their balance. Okay, and then we return true. So this is what gets done once you call this method right here. Now another thing we have to implement, of course, we talked about the transfer from, you giving someone ability to do some transaction on your behalf, and we say that it has to be someone you trust, has to be code you trust. Smart contract is what we normally use this for. So, and then this is approved. Okay. Our sanity check, making sure it's not a zero address. Then we update, by setting the amount we want to approve. Else we need to implement. Now let's talk about events. Okay, I believe that's everything so far. We've done it. Let's go back to this. I don't know why this guy is changing to white. Okay. We've implemented everything the core functionalities actually. The thing remaining now is the events. Now events are like a way for you to interact, tell the outside world what is happening in your contract, right? So if, for example, we want to build a UI, you can easily, pick out the values from the log, and this will enable us make some kind of valid interpretations as to what is going on. So to define an event, we use the event keyword, go up all the way. I think should do it somewhere here. Okay. So we use the event keyword. Name of the event, like we saw earlier, is transfer. Actually, there are two of them, right? The transfer and then the approve. So transfer, then we open it up. So it's gonna take address, and we index it. I want it to be indexed so that we can easily find it, right? That is from of the token. Then talk about the address of the tool. Also index this tool. In the amount we want to transfer, U256, right? After that, we terminate the process to get rid of that error. And the second event is approval. Event approval, right? We have the address, then which we get index. That is the owner now, the owner of the token, and then address of the spender. Okay, so the owner approves that the spender is going to spend so amount of token. That's basically what's going on here. And then spender. Then we'll talk about the value, right? Unit value 256. the value amount. Let's see amount. That's not what we want. We want amount. Okay, and then we enclose this as well as this guy. Okay. So now to emit the event, wherever we have which make a transfer, we have to like update the process and say, okay, so action actually happened at this point in time. We start with transfer function. That's the internal function we have. This is the transfer function. This function makes transfer, right? So once you emit this particular event, this place. After we update the balance, then we have to emit the event at this stage. Emit transfer. And then from, that's the sender. We have it here, right? So we update this guy from the sender. Oh, sorry. Sender, then recipient. Finally you're back to life. And the amount. Where else do we need to? I think our transfer from okay, before then, since we add events here too, when we deploy, because technically when we mint, okay, we are sending money to a certain address. This amount, we are transferring something to this, right? So hence we emit the event here. Emit another transfer. Right now, from talking about address 0. Address 0 and to who? Well, whoever we pass in the end, and it's usually the MSG that send that, but we can't define it here at the moment, right? And the amount, the amount. I believe that's about that for this guy. So we also need to, because when you approve a function, when you run the approve function, right, you are transferring something. Transfer is being done. That's from this guy to this guy. We're talking about the MSG.sender, right, to the spender. So right here we have this meeting. Say, okay, we approve this transaction. Approve. And then we have the MSG.sender, and then we have the spender, and of course the amount. So I believe we are good to go, except for our transfer from function, because definitely we have to update what is going on here as well. So we have the emit, trying to, here we are approving actually that we are proving that we have given this contract the authority to spend this token, right? Okay. So we have approval. Sorry. approve. Okay, so we have the sender here. Okay, sender. This guy should be the recipient, person receiving, which is also, I mean, the guy is also the recipient, and then the amount, sender please, not send, sender. Okay. So far, I think everything we need is right here. Are we omitting anything? So we move on to, can see our compiler is not complaining. It's giving us good that we are on the right track. So our deploy button at the moment is kind of disabled, right? So we have to pass in, because now this is happening because our contract has this guy here, constructor. So it's important, we must actually pass these values, must instantiate them. So name of our token, we want it to be maybe B UNN, blockchain UNN. Okay, let's write that in full, I guess, so that should be blockchain. Well, let's write the UNN there, and then we have the UNN. Now we've set the symbol and the name. That's what we just did here, right? So now we click this guy here, transact, and I think that worked. So our contract is here. I have the transaction hash, block hash, and so I see our events where they are being emitted. Now coming down here, you can see deployed contracts, and click this and we see what we have here. So if we click total supply, you can see we have 1009, which I believe is what we have here, right? So everything seems to be in order. Let's see the symbol as blockchain UNN, and the name in full now. The decimal is 18, like we stipulated right here. I should be 18. Let's try one of these, maybe balance of. Now this guy is meant to, if we pass an address, it will get the balance in that particular address. So let's try with this address here, the address we deployed the contract with. Let's see what happens. Click on this. I see we have this guy here, 1009, right? And that is this value here, which was minted to MSG.sender. And yes, the address we deployed with is the first address here. The rest are 100 ETH, and this is 99.99 because of the transaction fee we paid when we're trying to deploy the contract. Okay. Now let's try one of these. Approve. So approve takes address and also the value. So let's see. This is the guy that owns. So let's see if we can do this with this guy here. At the moment it's 100. Come down here, add address. We want to send this guy some token. Let's just say is okay. We want to send like say 1000, right? Now because I can't afford to count that, I'll just copy this set of zeros here. Paste it here, and then we transact. Oh, I made a mistake, please. Ah, I was supposed to go back to this other guy and then send money to this other guy. Okay, no problems. Let's try it again. By way of maybe. Well, I think we get the idea right. Or do you have any question? Um, I need some feedback, please. Okay, okay, to comment the code. All right, all right, all right. I'll do that before I'll send it over. Okay, so that we'll be happy. But so far, do we have any question? Okay, so that we know where we are and then where we are headed to. I need some feedback, guys. Do you have any question? Okay, battery low. We're almost done actually, so you don't have much to lose at the moment. It's okay, it's okay, it's okay. We're almost done. So, okay, okay. You have the opportunity to rewatch the video, and then if you have any question, you can always reach out in the group, WhatsApp group, and we'll be there to help you out. Okay, okay. All right. Now we are going to, the take home here is to interact. I'll give you this code that we have written, so you don't have to write it from scratch. You deploy it with your remix, then you try and do every single interaction here. Okay, we've done some. Attempt this, attempt that. If you run into any issues, of course, you can ask for help in the group, and we'll be there to help you out. Okay. All right. All right. Darlington, are you still there?
Yeah, yeah, I'm here. I'm here. Are you done?
Yes, 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 I'm done. Thank you.
All right. Thank you so much, Ceci, for taking out your time to like walk us through implementing an ERC20 token on Ethereum. I'm sure you guys learned something new, something valuable today, and of course, there's going to be an assignment following this class. So, uh, basically, the only assignment we've given thus far was the first assignment, which we gave after the first two classes. We're going to be giving an assignment which is going to cover like everything we learned about solidity fundamentals, and then you're going to be writing and deploying, not just interacting. We're going to write and you're going to deploy your own ERC20 token. So the idea basically is the name of your ERC20 token is going to be your surname, and the symbol is going to be blockchain UNN, BUNN rather, just like the way CC did it. I'm going to put everything, the assignment into writing in Google Docs where you would submit the link to your GitHub repository where you implemented the contract, and possibly I would need us to do like um a video showing like the interactions that we did on remix, because that's also very necessary. It's also part of the cost, like this part of the cost, right, to understand the remix. So we need to be sure that you know how to interact with your contract after deployment using remix. This is fine by us, right? Is it something very difficult? Doing the video just require having like a screen recording software and just doing a simple recording of when you're interacting with the contracts you've built. Is this okay? Is this clear? Do we have any questions? Of course, I'm going to put the assignment into writing, but I just want to know if we have any questions as regards the assignment, something you think that will be difficult to implement or you have challenges with. You could just unmute your mic and speak. Yeah, Chidibem, you could unmute your mic.
Okay, I want to know if this videoing of code is is very necessary for this assignment. I want to know whether I'm right about this.
We right about what? I didn't get your
Like
question.
necessary for us to video the code while doing the assignment.
No, 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 no. Like, do you mean like getting access to this particular the recording for this class? Is that what you mean?
No, no, you're saying that while doing the assignment, we have
Okay,
to
okay. No, no,
take a video
what I
of our.
yeah, what I actually meant was after you've written your contract and you've deployed it using Remix, as you can see by the side of CC screen, there's a place in deployed contract where you can interact with your contracts. You can call the balance of, you can call the decimal, you can call the name, you can call the symbol, as you can see on his screen right now. So I would want you to do like a video, a screen recording of you interacting with that. And okay, just to make things a little bit better, it's not compulsory, but it would carry extra marks. You could just keep it like that. So doing it could
Okay,
carry extra marks. So if you feel like you are constrained to not do it, then there's no problem.
okay, I understand.
Questions? All right. In the absence of questions, thank you so much, guys, for coming around. I know some of us definitely did not get some things, which is completely normal. It's like your first encounter with Solidity. So, in case the video is going to be made available because of the assignments. I'm going to try to make sure that the video is made available by max Tuesday evening so that you can get on with the assignment because the assignments you'd be required to submit the assignment by next week Tuesday. And also something we are now putting into consideration, right? I believe everybody's done with exams now, right? Is anybody still writing exams? Can you just probably raise your hands if you're still writing exams? Like you're not done with your departmental faculty exams. Anybody? I guess there's no one. So we're going to go back to our initial plan of having it 2 times a week. We're going to go back to 2 times a week. That's Tuesdays and Sundays from next week. It's still under consideration because there are a lot of things we need to adjust, including like the tutor's availability. So more information is going to be communicated with us before next week, before Sunday, the coming class on Sunday. But we have plans to like go back to the initial plan, which is like meeting 2 times a week in order to make sure that our learning is faster and accelerated and more in depth. And any other thing I'm forgetting. Um, like I said, I'm going to make the video recording available, so you could just catch up on it later, and it should assist you properly with doing your assignment. And yeah, one more thing, I talked about the fact that this particular class, right, we expect you guys to be way more serious. Like there's a reason the class is like very small and minute. Of course, we had over 150 registrations for the Web3 class, but a lot of persons did not really know what this entailed. And the reason why we streamlined the class to be just for people who are like who already have experiences with Web2 development is because we knew the class was going to be a bit too technical and quote unquote difficult, right? And you need a lot of tenacity to like pass through and complete it. And we also talked about how attendance to classes were really important. And we also talked about an eviction process, which was something I had to put aside because I understood that some of us were writing exams and we were having some challenges. But we are back to normal schedule, and for example, I can say our attendance is dropping from almost 28 persons. We just had 12 persons today, so that's very poor. So if you know someone who's supposed to like be on this call, just let them know that the whole um eviction process is back up, and so probably you might try to join the call next time and you'd not be admitted. people would communicate that also going forward. And I guess that's about it. And Favor, you want to ask a question? Oh, that's true. This recording is still continuing. Let me just stop this recording. As the class is over.